So thank you for your presentation on the lattice conformable and structures based on your long-term experiences. And you've emphasized a lot. It was very interesting, and I believe that it will be possible to do commercialization. Now, while we are not that much behind schedule, and the fourth speaker will be Mr. Min-Seok Kim from S-Fuelcell. He is the CTO of S-Fuelcell. He will be talking about the technology development and market status of PEM fuel cell in Korea. Nice to meet you, everyone. I am Kim Min-seok from S-Fuelcell. I am delighted to be here, and I will be presenting about the technology development and market status of the PEM fuel cell in Korea. And before I begin my presentation, I would like to once again congratulate the conference. And I'm delighted to be here and honored to be here to be giving the presentation. Actually, carbon itself is actually the hot issue nowadays. And in that regard, to be here, we're talking about carbon neutrality. And in terms of carbon neutrality, Korea, in order to achieve carbon neutrality, we are trying to move forward to become a hydrogen-based economy. And that's why we are focusing on hydrogen-related projects and businesses. And in order to become a hydrogen-based society, many carbon materials will be used. And in terms of hydrogen tanks, we will also be using hydrogen and fuel cells. And I will be focusing on that area. And also, and from Korea Fiber's presentation, we've heard about the carbon material and about the parts. And I will be focusing about using the carbon materials and composite materials and what kind of system can be made. And I will also be talking about the fuel cells. So the table of contents is as follows. So before I talk about the hydrogen society, I would like to begin by talking about Korea and globally about the energy paradigm, the changes that are taking place for the energy paradigm. And as you all know, right now we can actually feel the changes that are occurring and happening globally and domestically. We are no longer trying to use coal, and we're trying to avoid using coal. We are trying to use more of the natural gas, hydrogen. Not only in Korea, but also globally, there are many efforts being made. And in 2019, we have announced the roadmap to become a hydrogen society. The United States and the European countries are also coming up with a lot of policies in order to become a hydrogen society. So all in all, coal, we're moving away from coal and oil, but we are going towards the new and renewable and hydrogen-based energies. And as you can see, in order to become a hydrogen society, we need to generate hydrogen, we need to store, transport hydrogen, and also we need to be able to utilize hydrogen. So these are the three crucial parts, and we need to generate, transport, and utilize hydrogen, and that is the so-called hydrogen society. So in order to become a hydrogen society, we have to be able to do all of this, not only one, but all three of these crucial elements. And first of all, Korea is right now doing a lot of research and development in terms of utilizing hydrogen. However, generating or creating hydrogen and storing and transporting hydrogen, I think more researches have to be done in Korea. And so regarding the hydrogen tanks and storing hydrogen, I think we have to still do a lot in those areas. So utilizing hydrogen is about using fuel cells. And so we have to store hydrogen, and we have to liquefy, do the storing through liquefied hydrogen. And I will talk about the fundamentals of the fuel cells. As you can see, fuel cells uses hydrogen and oxygen, and through electrochemical reactions, it will create electricity, and that is the hydrogen fuel cell. However, until now, not only Korea, but also in other countries, we don't have much of the hydrogen infrastructure set up, and right now we need to begin with getting the hydrogen first. And in Korea, we are using hydrogen fuel cells for buildings, and we get that from city gas. So we get hydrogen from city gas, and that kind of a process is in place, and through that, we get the hydrogen from city gas, and with that hydrogen and oxygen, we have the electrochemical reaction. And in this process, when we get because we get methane, CH4 from city gas, and that C, we get the C, and then it will become CO2. And this is, as you know, this is the green hydrogen, the gray hydrogen. So by using the gray hydrogen, using the fuel cells, I mean, there are a lot of issues in terms of that, and that's why so we get the CO2, the CCS or CCUS. I think these two are the main issues that are being talked a lot these days. So when we get CO2, then that is the blue hydrogen. And when getting hydrogen, we should be able to get rid of CO2, and that will be green hydrogen. So in order to become a hydrogen society, we need to have green hydrogen. And using that, we will become a hydrogen-based society. And right now, we are in between, somewhere in between, in getting hydrogen and becoming a hydrogen-based society. So we are in the process of getting green hydrogen. So right now, fuel cells are being used. Of course, we can use directly hydrogen, or we can use it through city gas. And there are several types of fuel cells, especially in Korea. We are doing a lot of research and production of these fuel cells. And there are many companies and businesses that are doing research about these fuel cells. And as you all know very well, there are many researches being done from Busan and also for MC90. POSCO is taking the lead in those R&D. And also for SFC, Doosan is also doing a lot in terms of SFVC. And also for PEM-FC, I think Hyundai Motor Group is the leading company doing research. And also we are doing PEM-FC. And also DMFC is the smaller size fuel cells. So downbound cell or the Pro Power is also taking the lead for the DMFC. And right now, the products that are commercialized are PEM-FC products, and it's the low temperature fuel cells. So it can be more widely used than other fuel cells. It can be applied in vehicles or in buildings. And those fuel cells are the so-called PEM-FCs. As of now, in Korea and globally, the largest fuel cell market is Korea. And PFC is also a large market for the commercial use of FC. And also, SFC is another promising market, and this is the high temperature fuel cell, and the temperature would be about 800 degrees. Generally speaking, I think I also mentioned earlier that we are using electrochemical reaction, and that is the use of fuel cell. And if the temperature is high, then the efficiency is also high. And because we use the temperature of 800 degrees, that's why the efficiency is also high. So SFC is also a promising area, and if we focus on the cost of electricity, then I think SFC is also an area that we should be interested in, and many businesses are also currently very much interested in this area as well. So today I would like to talk about the PEM-FC, focus on the PEM-FC among all the other FCs. And of course, the system-related technology is important, and also there are many core components that comprise the PEM-FC. And today, I would like to focus on the core parts that consist the PEM-FC, as well as talk about the system. I will be going through those things briefly. So the basic for the fuel cell would be having a cell stack. And as I mentioned before, it's about having hydrogen and oxygen meeting together, and then we have an electrochemical reaction. That, in the cell stack, it takes place. And you can see the MEA, or the membrane electrode assembly, is the place where the hydrogen and oxygen meets and then creates an electrochemical reaction. And here you can see the carbon stack. And also we have the bipolar plate, as you can see. Generally, the bipolar plate, we use carbon. For buildings, we use carbon for the bipolar plates. And for the vehicles, because of the vibration, we use metal for the bipolar plates in vehicles. So in MEA, bipolar plate and gasket, this is the so-called single cell. And so you can consider it as a single battery. And if we attach several cells, then that is the cell stack. So this single cell, generally speaking, is used for 0.7 volt is used for buildings, and for transport vehicles, 0.5 volt is used. And then 100 and 150 volt can be generated. So this is the basic stack for fuel cells, and most of the research and development focuses on this cell stack, how we can make this more durable, how we can make it more efficient. So we focus the R&D on that cell stack. And PEM-FC cell stack, most of the technologies are standardized, not only in Korea, but also in Japan and also in European countries. The PEM-FC stack technologies are at a similar level. And next is about the hydrogen extractor, the place where we get the hydrogen from the city gas. So right now we use the steam reforming method. We use water and put in city gas, and then we get hydrogen. So that is the so-called steam reforming method. And this is actually you can think about the hydrogen charging station. So you can put in city gas, you create hydrogen, and we put it into the hydrogen cars. So that could become a commercial model. However, for the building fuel cells, this is all inserted in those fuel cells used for the buildings. So in this case, we have 3 types of reactions. So first, for the steam reforming reactions, it goes up to 700 degrees. So the reaction temperature is 700 degrees. And for the water gas shift reaction, because the temperature itself is very high, there is the system it affects the system endurability. So the steam reforming reactor itself, how we can create it to become more durable, and then it will become more reliable, and the system will become more efficient. And then we have right now for the building fuel cells, they have their own unique reforming technologies and techniques, and we also have our own reforming technologies as well. So as you can see above, these are plates, and below you can see that this is a cylinder. For the plates, usually the structure is simple. However, it can only be made for smaller sizes. But for the cylinder types, it looks complex, but it is easier to use for larger fuel cells. So this is a rough explanation of the fuel cell technology. As I mentioned before, in the middle, there is the reformer, and this is the stack. So here you can see that the city gas is inserted, and then hydrogen is created, and then it goes to the anode, and then through the cathode, and then air goes into the cathode. And then through the electrochemical reaction, and when it happens, the temperature is about 60 degrees. And then we retrieve it through water, and then we retrieve that temperature through water, and then we will get heat water or hot water. So we get the electricity and we get the water, so we can use both, the heat and the water. So generally speaking, the system efficiency, when we define system efficiency, then we look at the input and output ratio. So for the main parts or components of the system, so it's a cascade method. So we could have the same efficiency, but generally speaking, I told you about the reformer. The efficiency is 75%, and the cell stack is 56%, and then we have the pump and others as well. And we also have the inverter. From the stack, we get the DC electricity, which is used because we use AC electricity in households, and we get the DC from the stack. So when we multiply everything, then it's 35%. But if we get it from the CD gas, and when we consider the AC output, then we get 35%. So all in all, for the PEM system, the electricity efficiency is about 37%, 38%. And for SFC, the electricity efficiency can go up to 50%. So let's look at the system development up to now. And as you can see here, it's what is being used at our company. This is the development of our company. In the beginning, we have, in 2008, we have developed our first product, and currently we are also still selling this system. When we did the first development, the system size was about, right now the system size is about 450 liter, whereas it was 978 before in 2008 when we did the first development. So the system size decreased by half. And also the system efficiency first was 36%, and currently the efficiency is 39%. So here it says 36.3% and 49.1%, but this is not something that was measured internally, but because in Korea we also have an institution that does the measurement, that do the official measurement, and it was measured by that institution. And also the production cost, if it was 100 in 2008, right now it's 64% in 2020. And in 2008, we were able to produce 40 units. However, now we are able to produce 250 to 300 units a year. In fact, for the 1 kilowatt system, rather than the 1 kilowatt system, we are right now selling more the 5 kilowatt systems. For the 5 kilowatt systems, it was developed in 2010 in Korea, and in 2010 it looked like that on the left side. However, the system that is being sold currently looks more fancier, and this is we also got the Good Design Award this year. So this is one of the core products that we sell. And you can see that the system efficiency, in the beginning it was 33.2%, but now the system efficiency is 36%, so much higher than 2010. And as of now, these are the fuel cells that are being sold right now in Korea, the product lineup. And these are basically our products from our company. We have the 1 kilowatt, 5 kilowatt products. And here you can see we have the battery hybrid system where we use the battery and the hydrogen. And we use this system for emergency energy systems, so which means that if we don't have power or electricity, then we need to have emergency power. And so for fuel cells that use city gas, then because of that reformer, it's hard to get electricity immediately. That's why If we don't have electricity and we need emergency power, and in order to create it immediately, then the battery can cope with that situation. That's why we have the battery hybrid system, which can be able to get that energy, that emergency energy. And for the HG system, we use hydrogen directly, and because of that, we don't have the reformer for the city gas, and that's why the size of the system can become smaller. And this is the actual size of the system. On the right side, this is the 50K system. On the left side, you can see the 1K system. You can't see the depth in this slide, but you can see that the system size has become much more compact than before. I don't have much time. And these are the specifications of the products. I will skip. So now I would like to talk about the fuel cell market in Korea. In 2019, January, in Changwon, in Ulsan, President Moon announced the hydrogen roadmap so that Korea can become a leading country in terms of hydrogen. So that was announced in 2019. And among that, until now we've been importing energy sources, but now we will become an exporter of energy resources, and we will be leading the world in terms of hydrogen. So that was the announcement made by President Moon. And so we have the power generation for residential homes and buildings, and also for power generation. So in terms of power stations and all in all, we will be leading the hydrogen-based society, and that was the blueprint announced in 2019. And also we do have the relevant laws that were legislated since then. And right now this is the mandatory market law for the new and renewable energy resources. In order to build a public building, a new building, a certain percentage of that building should be renewable or new energy resources, and especially Seoul City, not only for public buildings, but also for private buildings. If it is a certain size, above certain size, then they have to consume a certain percentage of the electricity that they will use. It should be new and renewable energy. And right now, you can see that the Hyundai Motor Group is building a huge building in front of this site, and they will have to use a certain percentage of renewable and new energy. And you can see that this is the way it is installed in Yongsan. This is the largest type that we have in Yongsan. You can see the fuel cells. And I would like to briefly mention about our company S-Fuelcell. We were established in 2013, so it's not been a decade yet. But regarding fuel cell, we've been doing R&D even before that. And for the first company, we have been listed in Kosdaq in 2018. And right now, we are expanding our business areas. And as you can see, we also have the CE, we are working on the CE certification from Europe, and also we are working on government-supported projects. And that was a brief introduction of my company, so I would like to receive questions if there are any. Thank you for your insightful presentation. I do have two questions. The first one is about the PEM-FC and SFC, about the domestication rate, because including the materials, what do you think is the domestication rate? And for PEM-FC, about the development direction of the future. So right now, your question about the localization of PEM-FC. I think it's a sensitive issue because most of the R&D and business, they talk about the localization or the domestication. And for PEM-FC, I think the localization based on the materials, it's above 90%, especially recently. So the reason why I got to know about this International Carbon Festival is because of a carbon-related company located in Jeollabuk-do. And for the past 15 years, I've been working on fuel cells. And for the past 14 years, they've been importing the parts, but now they've succeeded in doing the localization or domestication of the part. And in the past, 30% was PEM-FC domestication, but now it's about above 90%. So for SFC, I am not really that much familiar with SFC, but regarding the SFC stack, I think for materials, I think that the domestication rate is not so high, but for system and parts, I think it's the similar level of PEM-FC, which would be about 90%. So I think a lot of R&D is being conducted, and I think SFC market is vitalized, and if it becomes more extensive, then I think the localization rate will become even higher. And as you say, for PEM-FC, the development direction of PEM-FC or the progress will be, well, until now, PEM-FC was more focused on the small size, like 10 kilowatt, 20 kilowatt. But moving forward, if hydrogen is created and we can provide pure hydrogen, then the SFC, like this SFC or PFC, and hydrogen gets into PEM-FC, then the cost can go up to 50%. So the overall direction will be to go to mega units. So for PEM-FC, I think the issue is to go mega. And as always, for fuel cells, the problem is about reducing cost, saving cost. So I'm not sure if that was a good answer, but that is the answer.
Thank you for your presentation. Thank you.